Raymarcher features a special collection of SDF objects called volumes. Volumes serve the purpose of displaying data on a three-dimensional grid and are predominantly used with 3D textures. As the 3D textures in the Raymarcher are used to display volumetric data, they also closely work with voxels in the Raymarcher. In this video, I will talk about two types of volume boxes. There are two types of volume boxes in the Raymarcher: Text 3D volume box and perspective-driven volume box. To create a volume object in the Unity editor, navigate to Game Object, Raymarcher, Volumes. Texture 3D volume box samples data from a target 3D texture. It can be used to display any volumetric data captured in Unity's 3D type of texture. You can assign your own 3D texture to the required field, or you can create a 3D texture using the Raymarcher Toolkit library. I will talk about converting mesh to volume in the next video. For now, I have prepared a simple 3D texture in advance. I will assign this texture to the required field. You can now play around with the params of the volume box. As you can see, the higher the volume precision, the more artifacts might appear. In such case, you need to increase the render iterations. I will talk about the Text 3D volume box later in the series, as this object closely works with the voxels. For instance, I have loaded a 3D texture that contains data of my tiny island with all the material mappings. It behaves just like a regular SDF object, and it works pretty well for a smaller scale. Perspective-driven volume box contains three 2D textures as input parameters. This volume box approximates 3D data based on the three 2D textures. It's not precise and does not actually display any data from a 3D volume. You can use this special volume box to approximately display regular meshes based on their visual appearance. Let's create a perspective-driven volume box and a renderer tool that is specially made for this kind of volume box called the perspective-driven volume renderer. Place both objects at the same place and assign the volume renderer tool to the volume box. I will add a simple model with an unlit material in the middle of the volumes and see the results. As you can see, it tries to copy the mesh I placed inside the volume. It's not precise, as the volume inside is displayed from approximated 3 camera perspectives. Let's try a character with an animation. This can be used for any data that you would like to quickly prototype as a volume. For instance, you can create a quick liquid effects out of a regular particle systems or a scanner that subtracts from a volume. This is the fastest and cheapest possible solution of displaying any volumetric object in the Raymarcher. It is also supported on all platforms, including mobile and WebGL. That was everything about the Raymarcher volume boxes. In the next video, I will talk about mesh-to-volume converters and expand this topic further. Thanks for watching and good luck!